Welcome to a Tech Talk on Power Automate and Azure Application Insights integration. My name is Emric Singh. I'm a Senior Solution Architect with the Fast Track team for Dynamics. We will start the session with a quick overview of the integration. Then we will proceed to getting started. That includes setup, telemetry tables and properties, followed by scenarios, alerts, and dashboards. And finally, we will wrap up the session with some useful resources, including dashboards and custom question queries we will use in this tech talk. We announced the public preview of the Power Automate Telemetry at the end of Focus. It was a long time coming, as Dataverse Telemetry integration with appinsights is out for years. Appinsights help you enhance the performance, reliability, and quality of your applications. It monitors performance, detects anomalies, and helps diagnose issues. To understand the importance of this feature, let's look at what other options are available. Power Platform Admin Center. You can find reports on flow runs, flow types, errors, trends, and connectors. Flow-level analytics in Maker's Experience. You can get similar reports like PPAC. In addition, you can get billable actions and flow run history. Data export to Azure Data Lake. It provides the ability to export analytics and inventory data to Data Lake. You can get flow definitions and flow runs, but you need to create your own reports. PowerShell commandlets. You can use these commandlets to automate some monitoring tasks. For example, get flow run can give you the flow run history for a specific flow. Similarly, you can also use management and admin connectors to get some monitoring information. As you can see, there is no one place to get the holistic end-to-end view of the Power Automate service. For example, you can't get the billable actions in PPAC. To troubleshoot issues, you need to go to Maker's Experience and look for specific runs. This is where this integration comes into the picture. It helps remove these blockers. In addition, you have some other benefits. You can monitor your flows in real time. You can identify performance issues. You can identify trigger failures. You can create alerts. You can analyze billable actions for critical flows. You can troubleshoot unsuccessful runs with the visibility to triggers and action at one place. You can create next best actions, such as creating a DevOps work item in case of failures. Getting started. This is how you link the Dataverse environment to appinsights. There are a couple of prerequisites. You need access to Azure subscription and appinsights environment. You require contributor, writer, or admin rights in appinsights. And in Dataverse, you need Power Platform Admin, Dynamics 365 Admin, or M365 Global Admin permissions. To set it up, navigate to Power Platform Admin Center, click on Data Export, then on New Data Export. Provide the name for the package. Select Power Automate. Select all the checkboxes and press Next. Select a managed environment. Now provide the subscription ID. Select your resource group. And your appinsight instance. Press Next, and then press Create. The data will start flowing to the application insights within 24 hours. Mostly it's much more quicker than that. To stop the data export, you can delete the export record. There are some prerequisites for this session. You should have a basic understanding of appinsights capabilities, some basic understanding of question queries. You should watch the introduction to Power Platform and Azure Application Insights integration, Tech Talk from our colleagues Tom and Amira. The Power Automate Telemetry is pretty simple. It is mapped to two standard schema tables in appinsights. Cloudflow runs are sitting in a requests table, and the Cloudflow triggers and actions are sitting in dependency table. There are some custom properties which are specific to Power Automate Telemetry. It's important to understand these properties as we will be using them to filter out our charts and custom question queries. On the screen, we have custom properties for flow runs, actions, and triggers. All the properties are almost the same. Resource ID represents the flow ID. Signal category differentiate Cloudflow runs, Cloudflow triggers, and Cloudflow actions. Organization ID and environment IDs are related to Dataverse instance. Resource provider is really important. It will help to filter out the Power Automate telemetry if you are pushing the Dataverse telemetry to the same app inside instance. Data object contain flow metadata information such as flow display name, run ID, XRM, workflow ID, created by, etc. Triggers and actions has an additional object named tags. In the flow request, it is a part of a data object. There are a couple of interesting things about triggers telemetry. It has an API field. It will have a value for automated triggers such as Dataverse. Also for flow triggers, the display name is missing in the data object, but it is present in the tags object. This query is very useful throughout the session. It displays the display name and flow IDs of the flows. It will be very useful if you need to filter out your charts or custom question queries for specific flows. Without it, you need to go to the Makes experience to figure this out. Let's have a quick look at the query. In the last slide, we spoke about the data object. So here, I'm reading the flow display name from the data object. Let's look at the custom properties. So these custom properties belongs to a flow run. If you look at the individual properties, we have organization ID, data, error, signal category, environment ID, resource provider, and the resource ID. The resource ID is representing the flow ID. The other important thing to notice here is the name field. The name field also represents the flow ID. You're going to see the similar things. For example, in operations pane, the operation name is a flow ID. Let's have a quick look at the data object. So we have a lot of information here. We have a flow display name. We have a origin run ID. We have environment name. We have a state of the flow, who created it, what kind of trigger type it's using. Let's have a look at the trigger. So if you compare the trigger custom properties here, most of the information is exactly the same, but you're going to notice we have an extra object here tags, and it has a similar information like a data object, but the data object doesn't have a flow display name here. And we also have an API property here. Let's move on to this display name query. So if you look at it, we got our flow display name and the flow ID. We're going to use this query to get the flow ID based on a display name throughout this session. Scenarios. Let's talk about metrics. Metrics provide aggregates of events over a period of time. That makes them an ideal candidate for dashboards and alerts. Just comparing the number of requests coming in versus failed requests can provide us a lot of information about the health of the platform. Let's start. Navigate to metrics under monitoring. At the first metrics, server requests. At the second matrix, failed requests. As you can see, we received around 92K incoming requests, and 44 of them failed. But this is not a true representation of a Power Automate platform. I'm also pushing my Dataverse telemetry into the same appinsights instance. So to get a proper picture, I need to add a filter. I'm going to choose a resource provider, and the value should be Cloudflow. As you can see, we received around 1.83K flow runs, and 5 of them failed. I don't want to go through the same process every single time I want to look at this information. So to avoid that, I'm going to pin this chart to my dashboard. So click on Save to Dashboard, Pin to Dashboard. Here you can create a brand new dashboard if you want to, but I'm pinning it to my existing Power Automate dashboard here. You can also filter this chart to look at the number of calls for a specific flow. To do that, we need to add another filter. We're going to pick resource ID and the value. All the values are just a GUIDs. So if you can't figure this out, use the query we shared earlier. This query returns the flow name with the flow IDs. Here you can pick a flow and copy the corresponding flow ID that we can use in our matrix chart. As you can see, we received 2 incoming flow runs for this specific flow and both of them failed. Analyze performance of flow executions. We could have used a matrix pane to look at the server response time, but out-of-the-box performance pane gives us much more options. Let's have a look. Here is the performance pane under Investigate. I have already added a filter, request resource provider is equal to Cloudflow, to filter out the Power Automate executions. This chart can give me much more than just the average response time. I can look at 50th, 95th, and 99th percentile of response time. At the bottom here, I got a table displaying operation name, duration, and the count. The operation name is representing the flow IDs. If I click on a 50th percentile, you can see the first flow is taking around 3 seconds. If I change that to 95th percentile, it's still around 3 seconds. But if I change it to 99th percentile, some of the flows are changed. The first flow is taking around 16 seconds. The second flow is taking around 5.7 seconds. If you want to know the display name of this flow, you can use the push to query I shared earlier. Here you can see the flow ID belongs to a flow IOM run registration. So obviously by looking at this, it's pretty clear that some of the flow runs are taking way too long. So the first flow, we have 145 requests. I can click any of these requests to get the end-to-end view, but I'm going to look for one that is taking around 15 or 16 seconds. So this request is taking around 15.7 seconds. This is the end-to-end transaction details. You can see the trigger. You can see the request. And you can see all the 3 flow actions. The request itself is taking around 15.7 seconds. The flow trigger is pretty fast, 30.8 milliseconds. This action is a try block. It's taking around 15.7 seconds. So now here, this action is taking around 15.6 seconds. So this is a real culprit. The action perform an unbound action is taking around 15.6 seconds. You need to fix that to fix the performance of this flow. That's how you troubleshoot performance issues in Power Automate. Yes, you can do a lot in a performance pane, but for the day-to-day use, you want to look at some custom charts and the question queries that can give you a quick glance at the performance of individual flows. Here we're going to look at 2 custom queries. The first one is going to give me a response time for individual flows. And the second question query, that's going to give me all the requests that are taking more than 10 seconds. So click on logs. Here you write your queries. So here in the query tab, you can see a lot of built-in queries there, but you can also write your custom queries that will appear under others. This is my first query. It's returning me the flow response time, 95th percentile flow response time for individual flows. So if you look at the charts, you can see different flows are represented by different colors that you can actually hover over it. You can see the different spikes, how long they are taking. So if you look at this, the name of the flow is IOM run registration is taking around 453 milliseconds. So this flow is taking around 18 seconds. You can click on the flow names in the legends and you can remove them. That can give you a better visual. You can also save these charts to your dashboard. And if you want, you can also create alerts here. For example, you want to create an alert if more than 50 requests are taking more than 15 seconds or 10 seconds. The second query here is returning all the requests that are taking more than 10 seconds. You can look at the different field names here. So timestamp, flow name, and the name of the flow, which is a flow ID. You can look at the performance bucket. So this is an interesting one because AppInsights does that for you. So you put every request in a different performance bucket based on the duration. So here you can see all the requests here are sitting in the same 15 to 30 second bucket. Let's look at the operation ID. Operation ID is actually a run ID. You can find that in a custom dimensions, but request is already having that under the operation ID. So this is really important. So you can copy this and use that to search all the transactions, triggers and actions and requests related to this specific run ID. You can filter the event types because, as you know, all the Power Automate telemetry is sitting just in requests and dependency table. So it will return you all the calls related to this specific run here. You can click any of these calls and it can give you end-to-end transaction. If you look at here, so the trigger is taking 2.5 seconds. The request is taking around 15.4 seconds. And if you look at this action, it's taking around 15.2 seconds. So this is taking forever. If you want to troubleshoot the performance, you may want to look at this specific action. Investigate exceptions. Same as performance pane, the out-of-the-box failures pane is the best place to start investigating failures. So this screen represents all the failures, including Dataverse. So the first thing I'm going to do is I'm going to choose a filter. Request resource provider is equal to Cloudflows. Or there are no failures in the last 24 hours. So I'm going to change that time to last 3 days. As you can see, we have 26 failures. So before we go any further, I want to point it out. The operations tab is bringing the data from the requests table. If you're interested in trigger or action failures, then you have to use dependency tab. Now coming back to the table again, the operation name represents the flow IDs. So we got 26 samples for the 26 failures. If I click on the first flow, now we got 16 samples. We can drill into to look at end-to-end transaction for those failures. So here you can pick a failure. As you can see, we got a trigger, we got a request, and we got an action. If you click on the request, you can see it failed. Look at the error code. An action failed, no dependent action succeed. So we're not getting much information. Let's look at the action. So it's a HTTP action. Scroll down. Look at the data. As you can see, the failure code is forbidden. It seems like it's an authentication issue in the HTTP trigger. So go have a look at that. Investigate exceptions, custom queries. So we have two queries here. Trigger failures by flow names, top failed actions by flow names. Let's have a look. So this query is about Cloudflow triggers. So if you look at the line 3, custom dimensions, signal category is equal to cloud flow triggers, which means it's only bringing back the calls related to the triggers. The next line, success is equal to false, which means we are just looking at the failed requests. The next thing we need to look at here is we are using tags object to get the flow display name. This is different than flow executions and the actions goals, where we get the flow display name from the data object. I think this is really important to look at the trigger failures because you don't get the run history if there is a failed triggers. So if you run this query now, you can see we have one trigger failure for HTTP request flow. If you want to know what's happening, what we can do is we can run the first 4 lines of these queries. Go to custom dimensions. Look at the error. Trigger input schema mismatch. So this error is telling me this HTTP trigger was expecting the body of the request in some specific format, and the client application is not doing that. So look at your client applications. So whatever you are passing in the body of HTTP request, it has to match the schema this trigger is expecting. Look at the top failed actions now. So again here, if you look at the signal category, it's equal to cloud flow actions. So we are just looking at the failed actions here. So if you see the results, we have 3 flows: call secured endpoints, copy of call secured endpoint, and HTTP request flow. If you look at, there are 18 failures for HTTP action. 16 of them belongs to copy of call secured endpoint, and 2 of them belongs to call secured endpoints. Flow runs and billable actions. This section is about platform usage. We have 2 queries here: top 10 flows by runs and top 10 flows by billable actions. You may argue that this information is already available in PPAC and at flow level analytics. But if you're using appinsights as a holistic monitoring tool, then it makes sense to have this information right here in appinsights. So this query is returning me top 10 flows by runs. You can change that to top 50, top 70 based on your environment. So the first flow here has 610 runs, and the second one has 602 runs in the last 24 hours. You can pin this chart to your dashboard. Let's have a look at the second query. Top 10 flows by billable actions. I'm actually really excited about this one because at the moment, this information is only available at flow level in the maker's experience. And it's really hard to get this information for the multiple flows or for all the flows in your environment. Let's have a quick look at the structure of this query. The most important line here is the line 3, where custom dimensions error contains skipped. The telemetry pushes all the triggers and actions information to the dependency table, including skipped actions. To get the proper billable actions or accurate billable actions, we need to add that line in there. So if you compare the numbers, you can see the first flow has consumed 1,827 actions, and the second one has consumed 1,821 actions in the last 24 hours. Continuing our conversation about billable actions, You may have a business critical flows or processes, and you are worried about your entitlements or throttling limits. Then these two queries are for you. The first query will return the billable actions for a specific flow over a 7-day period. You can replace the my flow ID with your specific flow ID, and you can get the results for your specific flow. So if you compare the numbers, this flow is consuming around 2,870 actions every day. I'll try to compare these numbers with the out-of-the-box report available at Flow Level Analytics. If you look at the numbers, they look exactly the same. So you can use this app insight query to get the same results without going to individual flows to get this information. So that second query here will return the aggregate of billable actions for all the flows in a specific process or process license. We don't have any report at the moment to achieve that, so this can be a good solution. Here, you add all your flow IDs in that specific process to the process flow array, and you can get the aggregates of all these flows. Alerts. Alerts are one of the biggest advantages of using application insights. Alerts can detect and address issues by sending proactive notifications and performing other actions, such as calling an Azure function, webhook, or a logic app. This diagram represents the process flow for alerts. The first step is Azure resources or web applications, pushing telemetry to logs or metrics. In our case scenario, the application is Power Automate. The next step is alert evaluation engines evaluating your alert rules on a scheduled basis. If the condition is met, an alert will be fired, and based on your alert processing rules or action groups, it will perform some action. The action can be sending a notification or performing some automated task. There are 3 parts to alerts: alert rules, action groups, and action processing rules. Action groups store your preferences for notifications. They are really important, as based on the notification type, you need to have an email address or a phone number ready. Or if you're using actions for automation, then you have to have your webhook, Azure function, or your logic app URL ready. Let's start with action groups. You need to provide the basic information like subscription, resource group, region, action group name, and a display name. The most important part of action group is notifications and actions. Let's look at the notifications. You have option to send email, SMS message, push, or a voice notification. Here I have selected email. So you need an email address if you want to send an email notification. You also need an email address if you want to send Azure mobile app notification. For SMS and voice, you need a phone number. Here I have enabled the common alert schema. I'm doing that because I want to use the same schema for different alerts, especially if I'm using a webhook, so the same webhook can process all the different alert schemas. Press OK. For actions, we have different options here: automation runbook, Azure function, event hub, ITSM, logic app, secure webhook, and a webhook. For webhooks, the only thing you need to provide is URI. Here again, I have enabled the common alert schema. Press OK. You can also provide the tags. The people use tags to categorize the resources and to view consolidated billing. Alert processing rules are not required, but it does add a lot of value to your alert management. It helps in managing alerts at scale. For example, you can assign the same action group to all critical severity alerts instead of creating different action groups for different alerts. Let's have a look. The first thing you need to do is to select a scope. Here I have selected my appinsights instance. Now look at the filters. Here I'm selecting severity as a filter, and I'm going to select the value equal to error. This is where the scale comes in a picture. I can use the same processing rule for all the alerts the severity is equal to error. Let's look at the rules settings. Suppress notification. So with this option, you can suppress the notification if you don't want to receive the notification. For example, just say you don't want any notification over the weekend. Let's look at the different scheduling options. You can apply this rule always at a specific time or reoccurring. You can pick a day, you can pick a start time and the end time, and you can also pick the start date and the end date. If you decided to go with apply action group, the first thing you do is select action group, Bootcamp Australia. Similarly here, you can assign the same processing rule or same action group to all the alerts where the severity is equal to error. The scheduling should be exactly the same, so there's no change here. In the details, the only thing you need to provide is a rule name. You can add tags if you want to. And the last step is review and create. I have created this sample alert on a flow trigger failures. Let's have a look. Add it. The first thing you need to provide is a scope. So here I have selected my appinsights instance. Look at the condition. This is one of the most important part. So this query will decide what we are trying to evaluate. So here I'm looking at the trigger failures. I don't need to provide the last 3 lines because the measurement part of the condition is going to look after that part. Here the measurement part is saying I'm looking at the number of rows, the count of those rows, and when I'm evaluating that query, I have to go back last 24 hours or 1 day. You can change that to 1 hour if you want to run this rule every hour. Then we have alert logic that will decide how often you want to evaluate this rule. So here I'm evaluating this rule every day, and I'm saying if the row count is greater than 0, then fire this alert. You can change this to 2, 3, 5 based on your requirement. And the last part here is a preview that can give you a sample data. For example, I can see there is only 1 trigger failure in last 1 day. Let's look at the actions. So I have assigned action group here. You don't need to do it if you're using alert processing rules. Here you define the severity and also the identity which will be used to run the search query. You can provide the tags if you want to, and the last step is review and save. That's it. Let's go back to alerts. So in the last 3 days, this alert is fired just once. I'm going to click on that to give you what it looks like. You're going to receive an email or you're going to call your webhook. This is the information that will be passed. So you have a severity, fire time, affected resources. You have the query which was used to evaluate this alert. And you have some other information there too. Dashboard. This dashboard is based on the charts and custom queries used in this session. This will be a good starting point to start your own dashboards. I'm not going to spend a lot of time explaining these charts and custom queries again. But let's have a quick look. The first section is general health and flow names. This chart represents the total flow runs versus failed flow runs. It will be really easy to spot spikes in the incoming calls or in the failed calls. On the right here, we have a table displaying the flow display names and flow IDs. Flow IDs are really important to filter out our charts or our custom queries. I put this table here so we don't have to go to the maker's experience to get the flow IDs. Let's move on to exceptions. We have 2 charts here. On the left, we have trigger failures by flows, as you can see, we have 4 trigger failures for HTTP request flow. On the right here, we have top action failures via flows. On the chart, we have 8 failures. They all belong to the same action applied to each for the same flow, HTTP request flow. Let's have a look at the performance. This chart is displaying response time for individual flows. This is really important as all flows are different. Some flows may have 4, 5, 6 actions, others may have 20. So if you hover over, you can see the name of the flow and how long it's taking. You can easily spot spikes. You can tell how long it's taking and the name of the flows. It's easier to tell the spikes are happening between 2 p.m. and 5 p.m. You can also remove the flows by clicking the name of the flow. Then you can get a better visual. On the right here, we have a table displaying flow executions that are taking more than 10 seconds. The operation ID is really important. You can use that to get the end-to-end transaction details. Billable actions for a specific flow or a process. On the left here, we have a chart displaying billable actions for a specific flow over 7 days. On the right, we have the same chart, but this time it's displaying billable actions for a process or all the flows in that specific process. Flow runs and billable actions. So the first chart is displaying flow runs via flows, and then the second one is displaying billable actions via flows. You can find really interesting scenarios by looking at this information side by side. For example, if you see a flow with a few flow runs but consuming a lot of actions, then you know that's a prime candidate for optimization. There are a few other things we need to look at. You can change the auto refresh time for this dashboard. And also we have time settings on a dashboard level. Right now it's 24 hours. If you change this to 3 days, you will see all the charts are refreshing except the last 2. So these 2 charts are still displaying data for the last 7 days. If you look at the filter icon at the corner, it's purple. It means these charts are overwriting the dashboard time settings. If you want these charts to display the data for the last 3 days, you need to untick this option. Resources. I have uploaded all the resources related to this tech talk to my GitHub account under Power Automate Telemetry repository. The repository has 2 folders and 2 files. The first folder, Dashboard Template, contains a template for the dashboard. The second folder contains a query pack template that contains all the custom question queries I have used in this session. The third file contains the important links, such as Microsoft Docs page for Power Automate Telemetry and the link to a Dataverse and AppInsights integration tech talk by my colleagues Tom and Amira. The fourth file contains the instructions on how to consume these templates. You can follow the steps from 1 to 7, or you can simply click on Deploy to Azure. Deployment is pretty straightforward. You click on Deploy to Azure, choose your subscription and resource group. You can also change the query pack name here. Review and create. Click on Create. So under the deployment details, you can see all the queries that's been created. So I'm going to show you what it looks like in the AppInsights. So click on Logs. Click on Queries. And here I'm going to select the query pack. Now if you look under Others, you can see all the queries. You can see the same thing here. There's another option. If you have too many queries, you can filter it by label. I have assigned a PA label to all my queries. To import the dashboard, click on the second Apply to Azure button. You choose your subscription and a resource group. The last two parameters there, the text parameters, I can't figure this out, how to change them to a drop-down or read these values straight from the subscription. So I'm going to type it in. My resource group name is exactly the same as my appinsights name. So I'm going to copy that. Click on Review and Create. Click on Create. It has been imported. Click on Go to Resource. Go to Dashboard. Now our dashboard is successfully imported. I don't have much data in here. I remember I used to have some data 4 or 5 months ago, so I'm going to change the time to custom to 1st of August. The other thing to remember here is the log tasks only show data just for the last 30 days. But you can see some data in the matrix chart here. That's it. Thanks for joining the session. I hope